Hello, in this video let's look at the development of atomic theory. Let's look at it from ancient times to the early 19th century. So let's go back to ancient Greece and talk briefly about natural philosophy. Natural philosophy was the predecessor of modern science, the forerunner of modern science. It involved reasoning and explanations about nature. People made observations, they didn't really do experiments. It was theoretical in nature. So they sat around, observed phenomena, bandied about ideas, and whoever had the best idea, best sounding idea, won. So this involved folks like Plato and Aristotle. And so let's say we were sitting around a campfire one night, and somebody threw a green log on the fire. You see the fire, you see the smoke rising from the fire and going up into the atmosphere and just dissipating into the air. If there's a green log, you can see the sap that's boiling out the end of the log, that's water. And when all is said and done, the fire would be the ashes that were left over as it returned to earth. So air, water, fire, and earth. And so those were the four elements. And the thought was that by combining them in different ratios, you could come up with the different types of matter that we have. And so jokingly, here's the first periodic table with the four elements: air, water, fire, and earth. Also during that time was a natural philosopher, by the name of Democritus. He lived about 400 BC. And he reasoned that if you took a stone and you can continually cut it into smaller and smaller pieces, then at some point there would be a piece that would be so small you couldn't divide it any further. It would be indivisible. And so he used the Greek word for indivisible, which is atomos, to describe these. And you can see where from the word atomos we get our modern word of atoms. So this theory was rejected by Aristotle, and so Democritus was put off to the side. In between natural philosophy of the ancient Greeks and modern science was alchemy. And alchemia, which means black earth in Egypt, was the forerunner of modern chemists. And so those alchemists, they were entrepreneurs. They were trying to find the philosopher's stone. They sought to change base, ordinary, common substances into gold. They wanted to get rich. They also looked for elixir of life, some sort of fountain of youth potion, and for some sort of panacea, something that would cure all diseases. And so they gave us the experimental foundation and a lot of data that helped lead us into modern chemistry. Then John Dalton comes along, about 1800 or so. He was an Englishman, and he is known as the father of modern atomic theory. And he has some postulates that he put out. He said that elements are made of extremely small particles, and they certainly are. And he called it atoms, borrowing from Democritus' idea of atomos. He said that atoms of a given element are identical. The atoms of different elements differ from one another. And that's certainly true in terms of the number of protons, the atomic number, which determines the identity of an atom. He didn't know about isotopes, where you could have different flavors, if you will, of an element that has different isotopes, different number of neutrons, but he was certainly on the right track knowing what he knew in those days. He said that atoms cannot be subdivided, created, or destroyed. So there's your law of conservation of matter, in that atoms can't be created or destroyed. We've since learned that atoms can be subdivided, if you will, that there are subatomic particles, and you can name those: proton, neutron, and electron. He said that atoms of different elements combine in simple whole number ratios to form compounds. H2O, 2 parts hydrogen, 1 part oxygen, gives you water. Whereas if you have H2O2, you've got a different compound, hydrogen peroxide, which has different properties. He said that in chemical reactions, atoms are combined separated or rearranged, and that's certainly true. He also said that atoms of one element cannot be changed into atoms of another element. And with that came the death knell of alchemy. There was going to be no transmutation, of trying to find some sort of chemical means of changing an atom of one element to an atom of another. Dalton didn't know about radioactivity, where unstable atoms naturally change into other elements. And in the 20th century, we were able to make synthetic elements by combining atoms together to make super heavy elements. And so that's a quick overview of the development of the atom from ancient times up until John Dalton, and we'll continue this conversation about a further understanding of the development of the atom in the next video. Thanks for watching.